So hello everyone. So today we are going to explore Arduino programming fundamentals. So let's start the basics by setting up our development environment. So for the IDE download, we will first need to download the IDE from arduino.cc. So just click on this website arduino.cc and here you can find out the Arduino IDE download. By clicking this website, you will be going to this thing Arduino IDE, and here you will be seeing this download link. So after clicking on this download, you can simply download this, and after the download we have to install this into our systems, and it is completely free and available for Windows, Mac and Linux. So just click on the software download and install it into your system. So now after downloading and installing, just open the IDE to get to know what the IDE comes with and features. So here you can see this is the board where this is the text and code editor. We will be writing all the codes here for the boards. In the tools, we will be opening the tools. Here we will be getting the board, and in the board we are selecting Arduino Uno where we will be going to work on. And for the port selection, we will be also using the same tools. Here you will be getting the port, and in the port you will be getting Arduino is connected, and on Windows it will be showing COM3, COM4, etc. On Mac it's something like /dev/cu.usb modem. If you don't see any port, check your USB connection or install the CH340 drivers if needed. And that's it. You are ready to go for programming. Since I am not using any port and USB, so I will be not getting bored. But as I have mentioned earlier, you will after your connection you will be getting the port like COM. Now going towards our slide, as we have configured our board and port after selecting the board, installing the board and choosing the correct port. Now, let's start the program structure and understanding them. Every Arduino Sketch program consists of two essential functions that control how to code executes. Now, understanding the program structure. Now that we have our IDE ready, let's understand how an Arduino program is structured. Every Arduino stage has two essential functions, the setup function and the loop function. The setup function runs exactly once when your Arduino powers on or resets. Think of it as an initialization phase. Here, where you are configure your pins, whether they are inputs or output, initialize serial communication, set initial value, and prepare sensors. For example, here void setup, pin mode 13 output, serial.begin 9600 is the port, 13 is the input. So going towards the loop function. So after setup completes, the loop function run continuously over and over again, thousands of times per seconds. This is where your main program logic lives. Reading sensors, controlling actuator, making decisions. For example, here void loop, here we have digital write, delay. This delay will wait for 1 second because the 1000 is 1000 millisecond, that's why it is going to wait. Then again digital write will, here as we have low, so it will be turning LED off, and delay will wait for 1 second. Now going to the next slide, commenting best practices. So always comment your code, use a single line comment with double slash for the brief explanation. Like here we have used set LED pin to output mode, so it is useful for the programmer afterwards. And use the multi-line comments with slash star and star slash for detailed descriptions. Good comments explain why you are doing something and not just what. For example, here you can see temperature sensor reading and threshold checking. So this commenting will be useful for future you, and you will be thanking the present you as well. Now let's dive deeper into Arduino's programming syntax. Understanding these concepts is crucial for building reliable projects. Now coming towards data types, so Arduino supports several data types. The most common ones are int, float, and boolean. The int stores whole numbers from -32768 to 32767. Use this for sensor readings, counters, pin numbers, etc. Example, this int sensor value or int LED pin, int temperature. These are all integers. Now coming towards the floats, they stores decimal numbers like 3.14 or 25.7, etc. These are perfect for calculations involving temperature, voltage, or any precise measurements. Example here are float voltage 3.14 or sensor value 72.5, etc. Now Boolean stores only true or false, so they are great for flags and states. Example Boolean LED state true or is pressed false, etc. There is also byte, long, double, and char, but these three will cover 90% of your needs. Now the next ones are the const and the define. Both create constants, but they work differently. Const creates a typed variable that can't be changed. For example, const int LED pin 13. This uses memory but provides type safety. On the other hand, define a preprocessor directive that literally replaces text before compilation. For example, here LED pin 13. So this does not use any memory. Use define for pin numbers and constant for values that need type checking. Now coming towards the operators and the control flow. Operators let you perform operations on the data. So here we have three operators: arithmetic operators, comparison operators, and logical operators. So arithmetic operators perform calculations like addition, subtraction, multiplication, division, and modulo. Here example are sum is equals to 10 plus 5. So the plus will add these two numbers and the diff will be subtracting these two numbers. Coming towards the comparison operators, these compare the values. For example, double equals to will check whether the two values are equal, not equals to, greater than, smaller than, greater than equal to, smaller than equal to. Here example, if temp is greater than 72, then the condition will be fulfilled and an action will be happening. Now coming towards the logical operators, these are combining the conditions. For examples, and or not. Example, if temp is greater than 75 and humid is also greater than 60, then only the action is to be performed. These help in complex decisions as well. Now control structures in action. Now control flow determines which code executes when, and these structures form the logic backbone of every Arduino project. Now, if-else statements let you make decisions based on conditions. This is perfect for sensor thresholds. Here's a practical example. For example, if sensor value is greater than 500, then only the LED will be turning on, else it will be off. So this reads a sensor and lights different LED based on the value, perfect for the monitoring systems. Now coming towards the loops. For loops, repeat a code specific number of times. They are excellent for creating LED patterns. Here's an example like for int I is equals to 0, I less than 10, I plus plus. This will create a loop for 10 times starting from I is equals to 0 to 9, and these are excellent for creating LED patterns or chasing light effect. Now let's wrap up with why all of this matters for our sensor projects and understanding these fundamentals means to you. Now these fundamentals unlock the full potential of Arduino. Whether you are building a temperature monitor, motion sensor, or automated systems, you'll use these concepts in every project. The sensor projects will using the read analog values, comparing against thresholds, trigger actions. The data types ensure accurate readings while control flow manages responses. The LED pattern projects uses the loop, create complex lighting sequence, variables store timing and states, while conditionals add interactively based on inputs. Coming towards the real-time monitoring, Continuous loop execution enables constant variable environmental monitoring. Proper commenting helps you troubleshoot and expand functionality later. Now, these are all the things that are used in an Arduino project or an IoT project. Thank you.